So in this problem, we have a copper refinery producing a copper ingot weighing 150 pounds. This copper is used to create copper wire for electricians with a diameter of 7.5 millimeters. How many feet of wire can be created from the ingot? The density of copper is 8.94 grams per cubic centimeter. So one of the things I find very helpful in this case is to draw a picture. So we know that we're going to create a wire. We know it is 7.5 millimeters, right? Because that's the diameter. And so we need a wire, and so we are looking for, in this case, the height. So we want to know how long this wire is going to be in this case. And so we are given the density, and so we also have the weight. And so we know that density equals mass over volume. And so if we know the mass, because it's 150 pounds, and we have an equation for the volume, perhaps we can now convert and solve for H. So our mass, we're going to need it to go into grams in order to use this. So let's go ahead and convert the mass. So if we have 150 pounds, and we know that 1 pound, because here are our known values, this would come on an equation sheet, is 453.59 grams. And so if we plug that in our calculator, we have 150 times 453.59. So the mass of this ingot is 68,038.5 grams. Now, it might be tempting to go ahead and start using your significant figures here. I find that you'll get a more accurate answer if you keep your extra values until the end of the problem and then reevaluate your significant figures. So in this case, we also need to look at our volume. So we know that the volume is going to be, pi r squared h. Now, we also know that our density per the problem is in grams per cubic centimeter. So I think it would be easiest if we solved for our volume and we only use centimeters. Now we'll have to convert the height into feet afterwards, but this will make our math just a little bit easier. So we know that this equals 8.94 grams per cubic centimeter. So we have a volume. So the radius of this is going to be half of our value here. So the radius equals 1/2 of 7.5 millimeters, but we decided we wanted to go into centimeters to make it easier to use this value. So we're going to go ahead and convert. There are 1,000 millimeters in 1 meter, and in 1 meter there are 100 centimeters. So our radius is going to be 0.375 centimeters. Okay. So now we're going to start solving our equation. So we know that the volume is going to equal pi 0.375 centimeters squared times h. H is the value we're looking for. So let's go ahead and set up this equation. So if we have 8.94 grams per cubic centimeter, oops, sorry, you guys can't see. That's going to equal the mass, which we solved here. So we have 68,038.5 grams divided by pi 0.375 centimeters squared times h. So we need to resolve for h, which is going to equal 68,038.5 grams over pi 0.375 squared times 8.94. When we plug this into our calculator, we want to make sure we use parentheses because that's the easiest place to get lost. So we're going to divide this value by pi times 0.375 squared. And we're going to multiply that by 8.94. Now the parentheses here are going to make it easier to make sure that all of these numbers are under the fraction. You could also set these up and then solve for them independently. So in this case, we get that the height is going to be this many centimeters. So we have 17,226.8 centimeters. But if we go back to the question, we're not quite finished. It asks how many feet of wire. So also on our equation sheet, we would know that 1 inch is 2.54 centimeters. And then in 1 foot, there are 12 inches. And so we can divide this value and get 565 0.18 feet. Now the real question is, did we use the right sig fig? So we can go back to the question. Density doesn't count. This value has 4, this value has 3. So our answer needs to have 3. So there are 565 feet of wire.